Hello everyone and welcome to C++ programming tutorials. In this C++ tutorial, we explain the concept of inheritance. Briefly speaking, inheritance is a very important object-oriented programming concept that is used to create new classes that use and combine attributes of the existing classes and that add new functionalities to the existing classes. The inheritance process enables us to reuse and add new functionality to the existing code. It also enables us to quickly implement new ideas and concepts. In this video, we present the essence of inheritance by using an example that you can see over here. But before I start with explanations, I would like to mention the following. Those of you who are my subscribers or who follow my work know by now that I always create a post that nicely summarizes everything that I will explain in this video, and consequently here's the post. This post contains codes and all the explanations. Furthermore, it took me a significant amount of time, energy and planning to create this post and this video tutorial, and consequently I kindly ask you to press like and subscribe buttons. Thank you very much. Okay, so let's start. Loosely speaking, inheritance is the process of creating a new class from the existing class and adding new functionalities to the existing class. The new class is called the derived class, and the existing class from which the new class is derived is called the base class. Okay. So we have derived class and we have a base class. I will explain this relation later on graphically. In its essence, inheritance implements is a relationship. For example, here are is-a relationships. A cat is a mammal. Here, cat can be seen as the derived class or the derived species, and the mammal can be seen as a base class. On the other hand, Honda Civic is a car. Here, Honda Civic can be seen as the derived class and the car can be seen as the base class. A circle is a shape. A rectangle is a shape. Here, circle and rectangle can be seen as separate derived classes from the base class shape. Now, here's a very important thing to keep in mind. Every base class inherits almost all the member functions and all the member variables from its base class. Depending on how the member variables and member functions of the base class are declared, we can declare them by using private, public, or protected access specifiers. The member functions of the derived class can or cannot directly access the member variables of the base class. We will explain the concept of inheritance by using the following example that we will also code in the sequel. Let us imagine that we work in an administration office of a university, and our goal is to keep track of student records. We can have several types of students. For example, we can have undergraduate, master's, or PhD students. For simplicity of explanation, we only consider two classes, undergraduate and graduate students. So, we have two classes. The first class is undergraduate student, and it's graphically shown over here. The second class is the class graduate student, and it's graphically shown over here. Both undergraduate and graduate students can be seen as derived classes of the base class student. So on top of these classes, we have the base class called student. This base class called student can store a number of records. For example, it can store student's place of birth, date of birth, social security number, student's photo, etc. Here, in order not to make this video too complex and not to make the code too complex, I will only focus on two records. The first record is student name, and the second record is the student's GPA. Now, since undergraduate and graduate students are also students, this means that both undergraduate and graduate student classes will store name and GPA. Name and GPA. So in C++ programming terms, we can say that undergraduate and graduate classes inherit the member variables name and GPA from the base class. So inheritance in this perspective means that these member variables are directly inherited by undergraduate and graduate students. In addition to these member variables, the base class called student can also have some functions or methods. For example, over here, we can have a section with functions or methods that are used to access and modify the data. We can have some other functions, etc. Inheritance means that the derived classes also inherit functions and methods from the base class. However, not all functions and methods are inherited from the base class. For example, constructors, destructors, copy constructors, and operator equality are not directly inherited. In addition to inherited member variables and member functions from the original or from the base class, our derived classes can have some member variables and functions that are not present in the original class. So in the case of the graduate student, we can have, for example, over here, a variable that denotes the number of papers that this student has published. On the other hand, undergraduate students can also have some other member variables. For example, we can store the student's current year over here in the variable. For example, the student can be in the second year, or we can store a Boolean variable denoting if the student has finished its necessary internship after the second year or something similar. Okay, so that was a very quick and very rough and loose explanation of inheritance. Later on, we will provide more details. However, for the time being, let us focus on coding. Over here is a header file of my class student. Before I start, I would like to mention that these codes are provided on my GitHub page. A link to my GitHub page can be found in the description below this video. In this class, we store two records as private member variables, and these records are student name and student's GPA. Then, as every class, we need to declare a default constructor. This default constructor will set the name to no name, and it will set the GPA to 0. Then we have an overloaded constructor over here. This is its declaration. It will take as an input name of the student, and it will take as another input GPA of the student, and it will simply assign these variables to our name and GPA. Then we have standard accessor functions for retrieving the student name and for retrieving the GPA. Then we have a function for printing data, and we have two mutator functions for changing the name and changing the GPA. Here is the implementation of this class. Here is our default constructor. This is pretty much standard. Here is the overloaded constructor, and this is pretty much standard. Here's the accessor function, we return the name. Here is the accessor function for the GPA, we return the name. And note here that we have const, meaning that these functions should not change private member variables such as name and GPA. Here's the function that prints the private members, and here are the mutator functions. So this is pretty much standard implementation, and there is nothing special about this code. Next, here is the header of the derived class called graduate student. And let us explain this code. First of all, over here, by saying class graduate student, public student, I'm saying that I want graduate student to inherit member functions and member variables from the base student class. Then I have here my constructors. Again, I have two constructors. I have graduate student constructor. This is a default constructor. And then I have an overloaded constructor. Then I have here an accessor function that will access this private variable unsigned int number papers published, and this variable will store the number of papers that the student has published. And in addition to this, I have another function called printDataConst. Now, if you go back and if you analyze the base class, you will find the same declaration in the base class. And here's this declaration. So in the base class, we also have void printDataConst, and in the derived class, we have void printDataConst. This means that we will redefine printData function in the derived class. In the sequel, we provide a more detailed explanation. Over here, we are directly specifying that the inheritance should be public. Public inheritance means that public members of the base class become public members of the derived class. That is, any member function or member variable that's public in our original base class becomes public member function and public member variable in the derived class. However, there is one catch over here. Let us go back to our original base class. Notice over here that name and GPA are private members of our base class student. This means that in our derived class, or better to say, in the member functions of the derived class, such as for example print data, we will not be able to directly access private member functions of the base class. That is, we will not be able to directly access name and GPA. Of course, since our graduate student derived class directly inherits all the public member functions from our base class student, we can still access name and GPA indirectly. We can use the accessor function. So over here, for example, in our print data function in the derived class, we can use getName and getGPA to get these two variables and to print them out. I must admit that this way of inheritance might create some issues, and it might be a little bit confusing. To avoid confusion and to avoid more direct inheritance, you can change this private access specifier to protected. By doing so, you actually enable member functions from your derived class to directly access these two member variables from the base class. To summarize, by declaring name and GPA to be protected, we can directly access these two variables from our print data member function of the derived class. Now let us analyze the implementation file of the derived class. The implementation file is given over here. All the codes are given on my GitHub page, whose link can be found in the description below. Here is the constructor of the derived class. Here you should stop for a second and analyze this code. First thing that you should notice is that we are calling the constructor of the base class. So over here, again, to repeat, we are calling the constructor of the base class. And here's the constructor of the base class. It simply sets name to no name and GPA to 0. After we called the constructor of the base class, we simply set number of papers published to 0. That is, we set the private member variable of the derived class, that is this variable, to 0. Now, another thing to notice is that over here I'm printing this message. So I'm printing that default graduate student constructor is called. Similarly, in my base class, I'm also printing this message, default student constructor called. This is very important in order to keep the track of the order of execution of your code, since once we create an object, first we will create the base part of the object and then we will create the other part of the object. That is the part of the object corresponding to the derived class. So let's go back to our implementation of the derived class. Even if I didn't specify over here explicitly that I want to call the constructor of the base class, the compiler will automatically call the default constructor. That is, it will automatically call the base constructor. That is the constructor given over here. However, it's always a good practice to explicitly call the constructor of the base class in the derived class. Next, here is the implementation of the overloaded constructor of the derived class. Again, this constructor accepts name of the student, GPA of the student, and these two variables correspond to the variables in the base class, and it also accepts number of papers that's used to assign the private member variable of the derived class. And again, over here I call the overloaded constructor of the base class, and here's the implementation of the overloaded constructor. And of course, I always print a message saying that this constructor is being called in order to track the order of execution of my code, in order to be able to better debug and to explain you the code. And I simply then initialize number of papers. And I print here the message. Here's the accessor function used to access number of papers published, nothing special about this function, and this part over here is very important. In order to be able to understand this part over here, we need to go back to our base class. So let us analyze this base class over here. Notice again that I have this function print data const, and I also have this function redefined over here, print data const. So I have the same function in my derived class and the same function in my base class. This means that I redefine print data function in the derived class. And let's look at the implementation. So here's the implementation. Over here, basically, I'm saying that this is a print function from the inherited graduate class. This is done in order to keep the track of the order of execution. Then, look what happens over here. Over here, by using this notation, I call the base class. So first I will call the base class print function. That is, I will call the function over here from the base class, and this print data function will print name and GPA. That is, it will print the part of my object corresponding to the base class. Then, after I print that, then I print number papers published. That is, I print the private member variable of my derived class. So this was a very nice and instructive explanation of redefining functions in the derived class. To repeat, you can simply redefine any function from your base class in your derived class by simply repeating the same declaration in the derived class and by providing in the implementation file different implementation. And finally over here I have my mutator function. I'm not going to use this function in this video. Okay, so let's see how this code works in practice. Over here I will change back this protected access specifier to private in order to keep the code in its original form. And I will save. Here's our main file. First, I will simply create an object, graduate student object, and I will simply print the data. And let's see what will happen. Compile the code, and let's run the code, and let's see what will happen. Okay, so let's analyze the output. What do we see over here? In the code line 9, I'm saying that I want to create a graduate student object called student2. I don't specify any inputs. This means that my compiler will directly call the constructor of my derived class. That is, it will call this constructor since there are no parameters. So let's look at the implementation of this constructor given over here. So this constructor will first call the constructor of my base class, and then it will specify this variable number papers published to 0. So going back to our constructor of the base class that can be seen over here, we should first expect the message default student constructor called, and let's see that. And here's the message, default student constructor called. Perfect. So going back to our constructor, then this variable over here will be initialized, and we will get the message after that default graduate student constructor called. And let's see the output, default graduate student constructor called. Perfect. Next, I call the function print data. And here you should stop for a second and think about, do I actually call the member function of my base class or the member function of my derived class? The answer is the following. I'm calling the member function of the derived class. Why is that? Because I redefined print data in my derived class. And again, here is the implementation. So what will happen over here? Once I call print data will actually call print data from the base class. It will actually call this function, and this function will print the part of the base class corresponding to name and GPA. And let us see the output. So first of all, I should get this message, print function from the inherited graduate class is called. This is correct, right? Then print function from the base student class is called. This is the part over here. And then I simply print the data. Since there is no name, I will get no name, and GPA of the student is 0. Once this part is finished, I will go back to my print data function from my derived class, and over here I will simply print numbers of paper published, and this is the number of papers published, and it's 0. Before I finalize this video, I would like to mention a few important things. First of all, let us assume that we defined a function outside of our classes that accepts an argument of the type student. That is, let us assume that we defined a function that accepts an argument of the type base class. For example, consider the following declaration. Function check is some function performing a few operations. Over here, I'm specifying that this function will use as an input argument an object of the type student. Now, since graduate student is also student, we can call this function with an argument of the type graduate student. In practice, this means the following. Let us assume that I define an object of the type graduate student. Then I can simply say function check, and I can specify over here the name of my object. That is, we can use an object of a derived class if a function or a variable is declared to accept an object of the base class. Next, although the default constructor of the base class will automatically be called from the constructor of the derived class, we prefer to explicitly call the proper or overloaded constructor of the base class from the constructor of the derived class. This is very important when the overloaded constructor of the base class allocates the memory. Then, a derived class does not inherit the constructors of the base class. However, we can still call the base class constructors from the constructor of the derived class. Then, assignment operator, destructors, and copy constructors are also not inherited. Next, instead of using the private access specifier, we can use the protected access specifier to define the member variables in the base class. In this way, we can access member variables of the base class from the derived class member functions. However, we cannot access the protected variables outside of the base and derived classes. Okay, that would be all for today. I hope that you like this video. If you like the videos I create, please press the like and subscribe buttons. Thank you very much and have a nice day.